Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. So yesterday definitely was a struggle, the problem and stuff like that. Hopefully today is a little bit better, and I guess it has to be a little bit better because yeah, we have an easy problem. So it'd be really sad if it wasn't easier. So we'll see how it goes. Today not much. I just kind of didn't do that much. I think I'm just resting a little bit mentally and physically, especially after a long week. And then just weekend we'll kind of do a little bit more running, hopefully ramping up a little bit. Because I would like to get back to like 25 to 30 miles a week, but just haven't really been in the good mental state to be able to do it, and just haven't slept enough, I suppose. So I don't know. Anyway, let's take a look at today's problem. We have count symmetric integers. You have a low and high, and integer x consisting of 2 times n digits is symmetric. Okay, makes sense. And of course we'll use the same trick. People call it a trick. I don't think it's a trick. I mean, it's just an idea. It's like something from your toolkit, right? Once you learn about it. So it's kind of a little bit weird to call things a trick, in the sense that it's like, oh, is it a trick to use sorting? I mean, I don't know, right? That's a little bit silly, but yeah. And of course, there is a easy solution for this, which is a for loop, right? 10 to the 4, it's fast enough. But we'll try to do a little bit better. We'll solve it for any number, and honestly, it should not be that bad, I don't think. Maybe I'm wrong. But yeah, we'll use the same idea as last night, which is this idea of prefix sum, right? Yeah, and the idea of prefix sum is just that, okay, well, if we count the number of whatever it is, it could be anything, but in this case it's symmetric numbers, but just from like, f of x is going to be equal to either 0 or 1 for whether it's true or not, so that you could sum up the entire sequence. Then now you have f of maybe 0, maybe 1, I don't know. It doesn't really matter where it starts if f of 0 doesn't matter, but yeah. So we want to add all this, right? So let's say we want to do this, then I kind of skipped. So yeah, so given this and given this, oops, something like that, right? So given these two things, then now you could figure, if you subtract this from this, then it gives you this, right? And the reason why you want to do it is because it's just easier to write, to be frank, right? In terms of like, there's a lot more edge cases if you're trying to like go through like if you just go through case analysis and if statements. There's a lot more cases going from low to high, because you have to consider if statements on the high side and the low side. Where if you go from 0, maybe not all the time, it depends on the problem setup. But you can, it's just much easier to assume you go from 0 to high, and then you don't even have like a lot of the low side restrictions melt away, and then you could use this thing, right? So yeah, definitely an idea that comes up often. So I don't know, people sometimes write it a trick, and I don't know, I feel like it's calling something like, oh, it's dynamic programming, is that a trick? I don't know, it's just an idea, an algorithm. It's something in your toolkit, right? It's like I don't know. But yeah, okay, so let's say we have okay, so do I actually want to do it today? All right, so you can definitely do some similar things to yesterday's with respect to whatchamacallit, with digit sum or digit DP, right? So what you would do is what we said yesterday, right? I mean, the idea is kind of similar. I think I'm not going to actually do it because I am feeling a little bit tired, so I lied to you, so my apologies if that was what gets you excited. But the idea is that, okay, so you have the let's say you have your x is something like this, right? This number. Then now you can just brute force. Oh, let me try another first number first. You just not brute force, but just count the number of ways that you can do it for each number, right? So we're assuming that we already kind of did all the other. I mean, and there are a couple of ways you can break this down, right? Here, let's just focus on numbers that are exactly 6-digit. I often like to do it this way, though apparently for yesterday's problem it was actually harder to do it that way, which I didn't anticipate. Often you don't have to, but because you can break it down to like, okay, one digit number, how many count. And for this one, the number of digits matter a lot more because you're talking about symmetry, and the number of things with odd digits and even digits kind of, it matters, right? Not too much. You could still do the math easily, but it's just like you have to consider it a little bit. So that would be factored in my consideration. And now that you have 6 digits, then we go, okay, how many symmetric numbers are there with 1 in the first digit, right? And then it's just do, right? So how many symmetric numbers look like this? And of course, if you think about it this way, then this can be anything, kind of, right? Well, kind of, because the first digit is a 1, so we know the last digit is a 1, so I lied about anything. But here, that means that there's it goes from 0000 to 9999, so that means that there's 10,000 entries, right? So there's 10,000 ways to have for this. And then you also kind of, I mean, in this case, all the prefix gives you the same number, so then you could just dot it all the way to, I guess, the dot didn't do anything because this is just the 3, but yeah. And then now you go 5, well, you can write this because that's not true, right? Because you have to fix certain numbers in the middle. So then that's where, you go, okay, well, we have to set the middle thing. So like in this case, okay, let's say the numbers is 0, then is that okay? Yes, because you have to set this number. So that means that any number with x is just any flexible things that you can do, right? So yeah, so that's kind of the idea behind the prefix sum solution. And honestly, now that I talked through it a little bit, it doesn't seem that bad to remember. I'm still not going to do it because I want to go to bed a little bit earlier. I have not slept that much, and it's easy. I'll just do the for loop, not going to lie. But I want to set you up for doing the harder one. And especially if you did yesterday's problem and you find it challenging and you want more practice, why not do it on this one, right? I think that's a perfectly reasonable thing to do. This one, and given digit DP, this is not a hard version of a digit DP, to be frank. Like you are going to face harder ones. This is probably an easier one to kind of go through this analysis and go through it. So this would that you practice a lot. And now that I hype it up a little bit, maybe I want to do that. But honestly, I am a little bit too tired to kind of do it. Maybe you could even see that my eyes a little bit, whatever, just like tired, right? And then here we go, okay, well, why 5, 2, do? Well, no, this one cannot be true, or it cannot be full flexibility because of the numbers in the middle. So then now you kind of like, okay, now this goes down, right? And then now just go, okay, well, in this case, is the only, oh, so this is not true, right? Or whatever, I don't know. Nope. And then like something like that, right? Right, and then all the way, and then that's it, because otherwise the number will be bigger than this number. So, and that's really how you would do it. Very similar to how we did it yesterday. So if you found yesterday's to be hard and you want it, but in a good way, or even in a bad way, because sometimes you just have to work out things that you don't like. But yeah, I would do it this way. But of course, it's fine if you don't. You could do a for loop, right? So here we go for x in range from low to high plus 1. We go, yeah, if I just write it this way, maybe reversed, then right, and that would be good too, right? So you can write that in about like 2 seconds, maybe a little bit more, but and you'll be wrong. What am I? Oh, what? Oh, this problem has a weird definition of odd digits, so that's why I didn't. Okay, I mean, I guess I was thinking of palindromes and not symmetric. And okay, fine. But I mean, that's just like, right? Anyways, I mean, that actually makes this a lot. I don't know if it's easy. I mean, I guess it's the same. It's just like changing your if statements. So I don't know. Right. Oh, oops. Huh. What am I doing? Well, apparently I suck at this. But, did I misread this problem? Maybe I just made it. Oh, I'm just sorry. I'm sorry. For some, okay. Well, okay. As you can see, I'm clearly not solving the right problems. I just misread this. I mean, this is obviously easy, but I just, for some reason, I read, I don't know, friends. I mean, it's very hard, right? But yeah, here, I mean, whatever. I'm just curious. All right, I mean, the easy way to do it, we could still figure it out, but I'm going to give it a thought about whether we can do digit DP. Let me reread this. The sum of the first n digits is equal to the sum of the last n digit, right? I mean, I don't think it's hard. Oh, well, no, let me take it back. I don't think it's conceptually hard, but I think it is definitely not easy. It is just DP, kind of like I mean, I think it's the same idea. But you definitely need digit DP for that one if you want to do it for like any number of digit, because then now just carry over. Now, is it just digit DP or is it just DP? I don't know if it's digit DP. Maybe it's just regular DP, to be frank. Let's see. Let me think. No, it's just digit. I mean, it is digit DP, and it is kind of tricky, but not impossible. It's just, yeah. The idea here it would be the same thing as regular digit DP stuff, except for like it's the sum on like the first n digit. Like your state will be the sum of the first n digit. I think that's enough, and then you just have to make sure that it goes. You know, the first half you're adding and the second half you're subtracting, and then something like that. So we're definitely not doing that today, but that's something to go, right? So yeah, so maybe we write like if good of x we increment, and then now we can just write this in the function. Sorry friends, apparently I solved the wrong problem or whatever, but yeah. So then here maybe we can just do right. Yeah. And then I don't know how you want to write this. How do you do a split? Okay, whatever. Let's just write right, and then now you can say right. I don't know. I don't even know if this is whatever. I'm just a little bit tired, so I'm kind of writing it like in a silly way probably, and even copy and pasting, as you know, but right, something like that. I mean, it's fine, right? Not a tough problem, but apparently I don't know. I just misread the easy part, but you can still do it in deep. I didn't do the odd digit thing. I thought okay. Oh no, I took it out when I rewrote it. Okay, but how do I? Is it this one? How do I click on? Let me add the test case is what I want to do. Yeah, I forgot about odd numbers, so that was just silly. Yeah, because I was focused on. I don't know. It reminds me of like I tell this story a lot about like when I go hiking. One thing that you get injured about, at least for me, is that sometimes you tend to like loosen up and like be like, oh, the hard part is over. I could relax and but it's not because on the way down, even though it's easier, that's where you could slip and die because and I guess I do a little bit extreme hiking because you let your guard down. And in a way, I mean, obviously the stakes are not as high for a easy problem on a Leetcode that on a random daily problem, but that's how it slips up sometimes. And if you really care about things, you do have to pay attention. But for now, I don't, so I don't care. But yeah, anyway, that is all I have for today. Let me know what you think. Thanks for watching. And this is exponential, the algorithm you want to curious because it is in the number of digits. And this is just going to take 10 to the n number of digits, right? If you want to do decimal digits, of course, you can reword that in binary digits. It's the same idea. But yeah, thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later. Take care. Bye-bye.